we give the definition of progressive measurability process, stochastic processes, and we will see why we need this property of progressive measurability. In plus, we will see what is the difference between progressive measurable and other notion of measurability like adaptedness or simple measurability. Okay, so first things, let's define stochastic processes. xt, it's a stochastic processes. I mean by this, like it's a family of random variable. So for every t here, xt it's a random, x for t fixed xt it's a random variable. Okay, so it's xt of it's a random variable. It means that it's measurable from the space omega f with value in some space of outcome which can be like r, br, or s, p, s. In general, S can be a metric separable space, or what we call it by a Polish space. Okay, so we have here like this is a random variable. It means like x minus 1 of b, it's in f. Okay, for every b, it's an open set in the sigma algebra PS. Okay, so here we can start by some definitions. Okay, so xt, it's first one. Xt is said adapted if for every t fixed this stochastic processes as a function of only one variable omega is n ft. It means that this variable is not just in f, but it's in a filtration ft here. Okay, so it's x minus 1 of b is n ft for all b open set in the sigma Borel sigma algebra PS. Okay, so here of course we suppose that our space has a filtration. Okay, so at each time t we can see it like we know the information till time t. Okay, and this information it's like included in this filtration ft. And we say that xt processes is measurable, not progressively, but it's measurable if we see it as a function of two variables. We will see xt of omega as a function of two variables, phi of t and omega, and this function of two variables, it's measurable. So this function phi t omega, of course it's from the space we can see 0, t in 0 infinity times omega. Okay, with the sigma Borelian sigma algebra b0 infinity product sigma algebra with f, our filtration, with value in s ps. Okay, so if this is measurable, if this function is measurable. Okay, so here like x minus 1 of b in the function apart of b 0 infinity times f. Okay, so here we looked at the function as a function of two variables. So the third definition is the processes xt is progressively measurable if and only if xt of omega, if we see it as a function of two variables t and omega, okay, but this time we restricted to the interval 0 capital T, for instance. This time, which I can also denote by phi t of t omega. So this function now, this phi t of t and omega is defined only in 0 capital T times omega, and we will suppose that we will take the sigma algebra of Borelian interval of the Borelian sigma algebra B0T times, and here we don't take all the big sigma algebra, but we will take just the filtration till the time capital T. And here the space of see here okay, see we how I call it, sorry, S P S. Okay, so here if this is measurable, this application is measurable. What do we mean by this? We mean that phi minus 1 capital T of B is in B0 T times Ft. Okay, so here you will see in other books, of course, that here instead of this capital T we have small t. So for every, this is here for every t. In the majority of book you will see like a small t instead of capital T, but it's the same. Okay, it's in any interval 0t. Why is it not working? Strange. So first thing, this notion of progressive measurability it's stronger, okay, imply the adaptedness and plus the measurability of the stochastic processes. Okay. Here, how we can see this? So let's take xt progressive measurable. Okay, progressive measurable. This is means that this application phi minus phi, can write it like this, phi t as a function of 2 omega as we spoke is measurable. And let's define, and we define gamma of t, gamma capital T, of omega, this function, by t and omega. So here it's a function from omega and give us a function in t, it's in 0t times omega. And of course here we can take only the filtration till ft. Can take any filtration, and here also, so our filtration here will be b0 t product with ft. Of course this map, it's clear, it's measurable from here, from this to this. Okay, you might just take a set from the second sigma algebra, this one, and take the inverse of gamma t, and you will find it in ft. It's not difficult, it's clear. So here, so if I make the composition of these two variables, I take phi t composed with gamma t. So here, so it will be a function from omega, okay, with ft, with value in the, okay, in s p s. This function now is the composition of the two measurable functions, so it's measurable. Is measurable, and we can see that this is what? So this is phi at which instant x of t omega, but applied gamma de t give us t, will give us t and omega. So it will be like x of xt or we start just from, or better, it will be like x okay. So we can see that this phi t or gamma t, it's equal to xt the omega. So what we prove, and this is measurable, so what we prove that xt omega, it's measurable. So I can write it here, xt omega is ft bs measurable, and this is for every t. And okay, and this is what we mean by adapted. Yeah, so for every fixed t or small t or capital T, we have shown that x, the process is x, is adapted. Okay. Okay, now we will show that progressive measurability implies the normal measurability. So, what we have, xt is progressive measurable. So this means that the application that we call by phi t is measurable in the appropriate sigma algebra. Okay. So here, if we take, and now we want to prove that it's measurable. So we want to prove that the application phi, which is not just restricted to 0t, is measurable. Yeah, we want to prove this. Okay, so for this we will take phi minus 1 of b for every b in ps. Okay, what we know that if I intersect this with restricted to 0t times omega, we get phi minus 1t, okay, of b. And this is, of course, we know that it's progressive measurable, so it's in the sigma algebra b 0 t times f capital T here. Or this sigma algebra is in the bigger sigma algebra, which is b 0 infinity, okay, times f capital F. Okay, so we have this intersection between this and this. It's in our sigma algebra. So if we take phi minus 1b, which is also, can say phi minus 1b, intersect with 0 infinity, okay, times omega, and this is you can see it as phi minus b intersect with this interval. We can write as union of 0 t times omega for all t okay, for all t in n. We can see that this interval we can write it like this. So if I take this intersection inside, we will have like the union of t in n, all t in n, of phi minus 1 of b intersect with 0 t times omega, and this is phi minus 1 t b. And we know that this is in b 0 infinity times, okay, times f. we have a union of countable union. So countable union of elements in a sigma algebra, it's also in the same sigma algebra, so we can deduce that all this apart it's in B0 T times F. Okay, and so we prove that X is it's a measurable stochastic processes. Okay, is measurable. See an example of processes which is like measurable and not progressive measurable. So here I take this example, I take omega, right? We take omega is 0, 1 and sorry, 0, 1 times F. I will write it like L, where L is the Lebesgue sigma algebra, okay? And here of 0, 1. So here what I mean by Lebesgue sigma algebra is the Borelian sigma algebra on 0, 1. Completed by the Lebesgue measure lambda, we call it. Okay. Let me see how big it was here, like this, and it was bigger, maybe. Okay, so, and here we will take Ft, we will take it this sigma algebra L0. Well, L0 is the sets in L, okay, such that their measure, the Lebesgue measure, equal 0 or 1. So the set with measures only 0 and 1. Of course, Ft it's in F, L0 it's in L, so Ft it's in L. So what we have? Ft it's okay. So Ft it's constant, but increasing, not strictly increasing, but it's increasing field sigma algebra, so it's a filtration. Okay, and here we take this set A, we take it like this, 0, 1, 2, for instance. Times 0, 1, 2. Okay, so this set it's in omega 0, in 0 infinity times omega. Our omega here is 0, 0, 1. Okay, so this is for the variable t, and this is for, okay, So A, it's so A appartain 0 to 0 1, and it's of course it's B 0 infinity open, okay, times L, okay, but so this state it's measurable, it's in this is measurable with respect to this sigma algebra, but if we take A but A is not in, we cannot see that it's in P 0 some capital T, okay, times Ft, which is L0, okay. This because if we take A and we take this projection in omega, okay, this is 0 1 2, and this is not with measure, it's not in Ft, it's not, which is L0, okay, it's not with measure 0 or 1, it's with measure it's with measure 1/2, okay. So if we consider these stochastic processes X, our stochastic processes X, okay, as a two variable T omega by 1A T omega, so this is equal simply of what, of 1 if T omega it's in A, 0 if T omega not in A. So we will see that the stochastic processes, it's measurable, but it's not progressively measurable, because if we see, so if we take the image inverse of indicatrix of T of omega of the, we have only two value of 1, it's equal A, okay, and we know this is in P 0 infinity times F, okay, but not in P 0 T times Ft, and the same for 0, yeah, we'll have A complementaire, so which is the same. So we see that it's measurable, yeah, but it's not it's measurable, but it's not progressively measurable. And what about if is it adapted? Let's see if it's adapted. So here we fix T fix A. We'll see A minus 1 A T, so the variable is only omega, yeah, of and the value it will be 1. So here t fixed. So this is the omega in omega, such that omega in omega, such that t which is fixed with the omega appartient. I want to see if it's ft appartient a. What is a? A is 0 1/2 times 0 1/2. Okay, so this is the omega in omega. So here we have two cases, like if t greater than 1/2, okay, t greater this cannot be verified, yeah, for all omega we don't have, there is no omega which can verify that this is. So this is equal to two things. So it's not verified if t greater than 1/2, but if t is less or equal 1/2, what we have? So t already in 0 1 2, so we need omega to be, we will have only the omega which is omega down omega, the set of all omega, okay, in 0 1, such that omega in 0 1/2. Hello, what is the measure all the omega? So this is only the set 0 1/2, yeah, and this is set 0 1/2. This is not in L0, it's not in ft, okay, L0, because L0 is the sets with measure 1 or 0, and this set is with measure 1/2, okay. So for every t fixed, xt is not in ft, so, and this is means that xt is not adapted, okay. Not yet. So let's see why we need the stochastic, why we need the progressive measurability. So here, if we need stochastic progressive measurability, we need that the stochastic to be progressive measurable if we want to work with stopping time in the continuous case, because when we define, for instance, in the discrete case, we have stochastic processes, okay, it's a family, it's a sequence of random variable, and okay, that for every n you have x, and the omega is a random variable, okay. And when we wanted to introduce x to the stopped processes, x to, okay, with to it's a random time, so it's a random variable from omega to n, okay. When we want to define this, we define it like this: x to of omega, like we define usually like x of tau, the omega, applied of omega, and we can see it as composition of two variables of phi, okay, phi of n composed with application tau I, tau identique, and with this phi n the omega, say it's xn or omega, okay, and here tau identity is an application from where? It's from omega, you can say omega times omega times omega, or omega is the same, okay, omega times omega, value in n and omega. Here identity doesn't make anything, okay, and we can see, we can like see it as this omega times omega. We can say that we can take this variable to be like just from as we define it, like from one space, omega, okay. So here with the filtration f, with the sigma algebra f, and here sorry, so here we can take the big sigma algebra sigma of all subset of n times f, okay, and here phi of n omega, this function phi of n omega, I had to not write it like this, phi of n omega. So it's in from which space? From space take from n times omega with sigma algebra to n f, and give us value in the space S B S, okay. So the composition of these two, phi or tau times E, it's from omega f with value in S ds, and this is what we define by x tau, okay. So in the discrete case it's not difficult, like here, to see that this will have this measurability, because here we have this sigma algebra, this total sigma, this big sigma algebra, yeah, subset of all the set of all subset of n, okay. This is the biggest sigma algebra. So we had xn omega is measurable from, we had this is measurable from for every n measurable from omega, so it's from f bs measurable, okay. And we could immediately, like, let it like exercise, check that x as n omega is f is 2n times f bs measurable, okay. So we can check this, we can that if we have a variable like this, measurable with respect to f, we can pass as a function of two variable, which is measurable with respect to this sigma algebra. But in the continuous case, this is not true. We cannot say that this implies this. We need to suppose that we have this in the continuous case. We have this measurability. Okay, so let's see what is in the continuous case. In the continuous case, we have xt, yeah, which is f ps measurable, yeah. But to define x tau, the omega, which we define it as x tau, the omega, which will be a function of two variables t and omega, or tau and identity. So to define this, we need that this is measurable. We need that this is f, this is p0 t times f measurable. Okay, but we don't have this. We have just xt as a variable of only one, as a single variable of omega is f, yeah, ps measurable. But as two variable xt, the omega, if we see it as a function of two variable, this is not in this. Okay, we don't know this, so it's why we suppose that it's measurable. And when we deal with the random time, but when we deal with stopping time, we will need the filtration, will come the filtration also, and then the things get more complicated, and we will need that to be here, like if at f at instant t. Okay, here already I should write here, and here at t. Okay, so we need that this to be in this sigma algebra if we want to speak about processes in evaluated in x in a continuous stopping time. Okay, so it's why we define the notion of progressive measurability. Okay, let's see another example here. So I told here that if we have xt, it's measurable with this. We don't have this. We don't have that as a function of two variable is still measurable. Okay, even with respect to the big sigma algebra. Okay, b of 0 infinity times f. We can say an example here. We can take a set A which is in 0 infinity 4 times, yeah, set from the time interval such that A is not Borel sigma, it's not in this Borel sigma algebra, and we know that there are sets which are not Borel in 0 infinity, which are not Borel b0 infinity. Yeah, they exist some set, yeah, there are not in this. And we can take here processes A x. We take processes like this. depend only of t, doesn't depend of omega. So this processes, it's like if t is in A equal 1, and if t is not in A equal 0. That xt, what? Xt of omega for all t fixed, yeah, for all t fixed, we have xt of omega equal to value 1 or 0, yeah, equal 1 or 0. So it's a constant, and we know that a constant is measurable. Okay, so is f. So we should take here omega f is a probability space, so it's f measurable. But then when I will speak, if I will try to see if xt omega as a function of two variables, t and omega. Okay, so this is equal what? As a function of two variables. I want to see it as I think this, I don't write it like this, but this I can, like if t and omega appartenant à a times omega, this will be 1, yeah, and equal 0 if t omega appartient a complémentaire with omega. Okay, so phi minus 1 of of 1. Okay, so here is enough for 1. Phi minus 1 of 1, it's a times omega, and phi minus 1 of 0, here it's a complémentaire times omega. And this is by definition, because a is not in P, so this is not in P, 0, infinity times f. Okay, and this is not in the same. Times f. Okay, so this function is not, it's measurable, as for every t it's measurable, but it's not like as a function of two variables is not measurable. So here for this function I cannot speak about stopping time, yeah. So here if we fix t, here I didn't introduce ft, okay, I didn't introduce. So when we will work also with the filtration, okay, and instead of stopping time, random time, we work with stopping time. Okay, we will need the progressive measurability. Okay, to, for instance, to show that our processes which is stopped at time tau is in f f2, sorry, f2. Okay, the stopped sigma algebra sits a in f capital T such that tau is enter a is in f. So to show something like this, we need progressive measurability. Okay, maybe I will stop here.